Can you hear me? Yeah. Hi, my name is Laksh, and today I'm gonna be talking about how to get into machine learning, just hacking your way into machine learning. And okay, so this talk is basically for the guys like who knows Python and is new to machine learning. And okay, so what is machine learning? So the thing is, machine learning has been very famous since I think 3 or 4 years now, and it was hyped in back started like in 2012. And so basically, machine learning is the field studies that computers the ability to learn without being explicitly programmed. So that what basically means is like you don't have to write for every conditions if and else, right? When you write a program and then let's say you are writing a program for anything, and then there are some few conditions to that program, like for some input there should be some output, and in machine learning you don't have to do that. So let's say if you are trying to recognize a tree using some Android application and it has a machine learning capability, then you just have to click the picture, and if your model is trained correctly, it will be able to do that without explicitly saying that this is a tree in your code. Okay. uh, Okay, so why machine learning is getting famous now? The thing is, like back in 2010, NVIDIA and AMD GPUs was doing some research in their R&D department, and they were able to find, accidentally, they were able to make some hardware which was very faster. And since then, the computational power has been like increased and everything, so all of our programs run. And that's why the machine learning theory has been there for 30 and 40 years, but that's why in this decade, like we are seeing it very famously and everything. And the the machine learning important part is that just I told you that we don't have to like machine learning will be able to do repeatable decisions on its own. We don't have to write anything explicitly about that, right? Okay, so what's the workflow to start with a project or anything, and by the end of it, you will be able to get a model and which is like doing some task that you wanted to do it. So the first thing is always that you have to get some data, and then you have to process it, and then you have to create some model over it, and then you can implement that model in anything, either in web or in Android or in iOS or like however you want it, or just use it for research purposes. It's up to you. But this is the whole workflow. So when you in data, you have to collect the data, or like what are the data sources. So let's get that into. So collection methods are like two types mostly, which is like application program interface and scraping. So API is basically, so most of the people think that getting data is illegal, but it depends on the provider of the data. Like if you just start scraping Facebook for some reasons, that's illegal because it's in their terms and conditions that you are not allowed to do that. They have particular APIs for that, which provide some endpoints, and you can get that only particular data from it. And sources, so there are open sources like Kaggle and UCI machine learning repository. So they provide data to you. So whatever happens with the data, it's on their own. Like if they are doing something illegal with that data, it's their responsibility. You can use that data and nothing, no responsibility will come to you unless you use that data for some negative impact or something like that. So today I'm going to use a practical example. This is a wine dataset which is available on UCI repository. Everybody can download it, and there are a lot of datasets over. I think there are like, I'm not sure, but it's a lot. Like there are 50 categories over it, and then you can get the classification problems, regression problems, and all of that stuff. So in wine datasets, there are about 12 attributes, which states that like how is a wine made, and the main attribute that we have to predict is like the quality, the last one, which is like if you give all of those inputs as 11 columns as input, and it will tell you like what's the quality of that wine. Is it bad or is it good? Oops. Yep. Sorry for that. Yeah. So so we will be using Python, of course, because it's PyCon, and so the libraries that are provided in Python is pandas, numpy, matplotlib. These are the open source library like which is very great, and they are open source. Anybody can contribute to these libraries. It's open source and everything, and they are provided with like num focus contributions. And these are the best libraries. There are other libraries also which are like private made and everything, but like Facebook and all those Twitter have their own libraries. They don't. They use these libraries just for basic purposes, but they have on their stack, but those are not available openly. So these are the available that's to us. Okay. Uh, so I'm gonna start showing now the code of Python and everything. So the first thing that I told you that we have to get data. So the data I got from UCI, and after that we have to. So the first cell here states that what libraries I'm importing. So the first line is pandas, the second is numpy. Uh, the one library I actually missed it is scikit-learn, which is for, of course, modeling, machine learning models, and which is called sklearn. And okay, the second cell says that ed.read_csv, which is like we are reading the wine dataset. It's available in CSV to us, and it's also available in another formats, but CSV is the easiest format you can use. So CSV is common, if nobody knows, it's comma separated values. You can also open these these CSV files in your Excel just to see it, or even in your notepad or whatever. So first we read the CSV file in data variable, and then pandas, we are reading with pandas pd.read_csv, and then we do data.head. That means that we want to see the head of that file, which is like the headers, the column names, and the top 5 rows. Okay. You can see here that those columns are the same columns that I showed you just in the last slide, like the acidity, volatile acidity, citric acidity, and the last one is the quality, which is like 3, 4, 5, 6, 7, 8. That basically means the quality. The lower the worst, the higher the best. So 8 is the best here in this data set, and lower is the 3, lower limit. You can also get more detailed information about the dataset in pandas using .info. So .info function is tells you like how many exact columns are there. So there are 12 columns, how many entries are there, and in each column how many entries are also there. Like the first one is the maximum, 0 to 1598 is the maximum rows of the dataset. But for individual columns, it's also stated that 1599, 159, like everything is 1599, which basically means that there are no empty values, right? So if there will be empty values, we have to fix that in later processes. But if all of the numbers are same, that means that our data don't have any null values or something. And it also states that it's non-null. And in the last column, it states that what type of data is. So 11 columns are float 64, which basically means that each of these columns has value between like 0.45 or 5.67, something like that. And our quality is described as int 64, like I told you, 3, 4, 5, 6, 7, 8. So yeah. So now the first step was to collect the data, which we saw like how is the data, and now we are going to process it. We cannot just put it into our machine. Like most of the people thinks that it's just collect the data, put it into machine learning model, and we are done with it. That's not the whole thing. We have to process it beforehand. That's what data analytics or data scientists do actually. So the first thing in pre-processing exploration. So data exploration is a approach where like we do visual exploration and not statistical exploration. So that's a different thing. So here what it means basically like we will be doing bar graph or box plot or any graphs you want to check out using the data and to see what are patterns there just from us. So here I'm using, so I told you about the matplotlib library, which is an open source library. Recently, there is also one library, Seaborn. It's now very famous. It's built upon matplotlib. So like why Seaborn is useful is because in matplotlib, if you have like probably for this graph, you have to write about 7 or 8 lines of code. In Seaborn, it's just one line. You can see that it's just one line, and the graph will be there. So Seaborn is very useful, but it is built upon matplotlib itself. So this is one of the graphs which is basically I built using the data, and it's a correlation box, right? So you can see the diagonal is, so basically that's the labels. Minus, yeah, so the middle is 0, it's 0. Negative is -1, and the highest is 1. So 1 means that it's positive relations, and negative means it's a negative relation between two columns. So you can see the diagonal is always the cream color, which is like, you cannot see the exact color, but the diagonal is cream color, which is 1.0. That means that, like you can see the quality, and this is also a quality column, so which is like cream color, which basically means that those are positive relations, right? And if you want to see the negative, which is like -1, you can see on the second row last column. Yeah, it's like volatile acidity and the quality. So the correlation between quality column and the volatile acidity is negative relation, right? So which basically means that if volatile acidity is quantity is growing up, that means the quality of the wine is going down. So which this you can see it here. So we will go into that a little bit ahead. Okay, yeah, so this is the first one, citric acid. So this is a box plot. I'm also using the Seaborn here. Okay, so the x-axis states the quality, and the y-axis states the citric acid. So you can see that if citric acid increases, the quality is also increase of the wine, but yeah. So as I told you before also, that if we saw in the box plot, the correlation graph, that if volatile is increase, yeah. So the quality as increases, the volatile is negative, right? So it's the negative relation between it. You can see it. So, and the third one is the alcohol quantity of the wine. It's not that, but it still states that if the quality, if we increase the amount of alcohol, the quality is also increasing a little bit of it. So we did visual graphs now, and now we have to manipulate our data according to our scikit library. And if like in this data set, we don't have any empty values or anything, but if it would have been, we have to fix them using mean or median of the data sets. Okay. So our quality had the numbers between 3 to 8, 3 being the worst and 8 being the best. So what we're going to do is, like, we're going to change those quality to bad and good. So there will be only true or false, like is this wine good or is this wine bad. So that's what I did. In bins you can see 3, 6.5 and 8, which basically, so bins is like you can take the whole data set and convert it into a particular bin. So if we are working on a time series, that basically means that let's say we are dividing one whole day, 0 to 24 hours, into 12 bins. So that basically means each 2 hours is one bin, right? In this case, what we are doing is converting like from 3, 4, 5 and 6 to one bin, and 7, 8 to another bin. So 7, 8 is the best wine, 3, 4, 5, 6 is the worst one. So that's what we're doing, the bad or good. So I name it like since a scikit library never works upon the text, so we have to convert everything into digits. So 0 means bad, 1 means good, and so if and like the data quality. So right now we are selecting the quality column of the data and we are changing it with our bins that we stated above, and we're just gonna change it with the 0 and 1. So 0 means bad, 1 means good, and you can see in the quality column last each of them were actually 5 in the starting. Now they are zeros because 0, 3, 4, 5, 6, right? Now if we count it, 0 is 1382 and 1 is 217. So what that basically means that we have 1382 bad wines and we have 217 good wines in our data set. You can also see in the box plot here. So when we get the data set from anywhere, it's going to be serialized in some manner, right? If you scrap it or if you collect it or whatever. Even if you saw before, all zeros were all together in quality, which basically means that all the bad wines are same at like together. So we have to randomize our data set first so that the training or testing data set is not biased to any of the labels, right? And if we split our data set, let's suppose we split our data set into 80 or 20% or 75 to 25%, then and we don't randomize our data set, which basically means that all the top ones goes to train and all the bottom ones goes to test, which basically means that our whole data set is not in the same category because all the bad ones are up there, all the good ones are in the testing, right? So first we randomize our data set using NumPy library. So np.random.permutation, it's available in their docs and everything. So what it's doing is like there are if there are 100 rows, it just shuffles it up and maybe 101 comes to the first one or third one or whatever. So if the whole data set is shuffled up, and after that we distribute our data set into training set and testing set, then it will be able to generalize, our model is able to generalize better. So now we have to convert our data set into inputs and output, the target label which is quality and the input which is like the first 11 columns. So X here states that it's the input and Y here states that it's the quality column. So here you can see our data dot drop quality column, which basically means that I am dropping quality column for the training and for the input, and for the labels I'm just taking the quality column here in the cell number 22. After that I'm splitting the data set into 75% and 25%. You can do 70-30 also or 80-20 depending on how much data is available to you. So if you go below 70, which basically means your training set is not getting a lot of data to generalize on or to learn about, right? And you are giving, and then you are trying to test it over, let's say 40%. If your split is 60-40 and 60% is your training and 40% is your testing, then maybe there will be some cases that machine learning has have no clue about, and it's gonna perform bad when you test it on your test data set. So 75-25 split is okay. 70-30 works sometimes also. 18-22. Yeah. So first I calculate the number of rows in data, length len data, and then I just multiply it by 0.75 to get the number, 75% number, and then I just split it according to using the X split and then X colon split, which basically means that the above 75% is in training and the bottom 25% is in testing. So now comes the model selection. We collected our data. We also pre-processed our data. Now we have to train our data. So there are basically two methods, like classification and regression. There are also a third one, which is clustering, but we are not going to do that. So in classification, you got decision trees, random forest, k nearest neighbors, neural networks, and in regression, random forest also, we got random forest regression, linear regression, neural networks, and more other methods which are available in scikit-learn. I think there are about 15 or 20. There is also naive Bayes and all that. So I'm going to use decision tree first. So decision tree is like, it takes the data, it converts into a tree, and the root node is the split between it. So let's just, so in scikit-learn, it's very simple to use the model. It's just these three lines. The first line is to create a model, second line is to fit the model, third line is to score with the model, and that's it. But the main thing is to pre-process the data and make sure that your data is good, that you are training it on. So here I am making first decision tree classifier. I imported it on the first slide, and then I am fitting it over my training data set. So what fit here means that it trains over data set in the RAM and everything. They use fit and not dot train. It's their functions. So, and then you can score your model on test data set. You can see that it says 0.8231, which basically means it's 82.31 accuracy. So that's kind of good, like you get above 80%, right? But if you are going to try it in production level, and then you cannot say that my model is just on 20% loss, it's fine, you can just use it on production. So you have to increase your accuracy somehow. So one of the method is to use random forest, which is always better than decision tree, because random forest is like, random forest is the collection of all of the decision trees. So like here you can see it says n underscore estimators is equal to 10, which what means is here we are training 10 decision trees and using all of those accuracy to get the best out of it, all of this 10. And then that's what random forest means. Like decision tree is one tree, random forest is just in the name of it, random forest, which basically means the collection of trees, and decision tree is just one tree. So if you change n underscore estimator to 100, that means you are training 100 trees, and then you are getting the best out of it, and then just making a one particular model. So here you can see that I did nothing, but just made a random forest, train on the same training test, and train on the same data set, and also tested on the same one, and I got about 85.4% accuracy. So it's the same data set, it's everything, it's just I am using here n underscore estimate is equal to 10. Maybe if you do n underscore estimator 20, then you will get the best one. Like maybe 87% or 88%, you can try it over. Sometimes it also happens that if let's say you try 10, then you try 20, and then you try 30, and with the estimators equals to 30, your accuracy goes below. It can happen because there is some level at which the best one is there, right? After that, it's just going to worse and worse. Not every time. It's not like if you increase the numbers, it's gonna increase your accuracy. It might get stagnant at some point, like 85.5, 85.5, 85.5. That happens a lot. So you have to find a particular number at which you can train your random forest and get the better accuracy in less time. So that's it. Any questions?
Okay, it's time for the questions. Anybody has a question? No?
Could you please go back to the previous slide?
This one?
Yeah, you just said that, so now we could pick different parameters of the random forest classifier,
Yeah.
and then we can like see better accuracy. But that's like how I know that would be overfitting, and we cannot kind of see the test accuracy and anymore. We should not touch parameters anymore when we saw the test accuracy. So if we split, like we have validation set usually, and we train the model on training.
Yeah.
Then we validate on validation, and then we see accuracy, and then we choose parameters and so on. We do it many times, and then we like see the final accuracy on the test set, and then we don't tune parameters anymore. That's forbidden, as I know. But correct me if I'm wrong. So that was for me.
Yeah, what
The
you are saying
question.
is like in that case, what we do is split our data set into three parts, which is like training, test, and validation. So yeah, I get your point that after checking out the test accuracy, you cannot change your parameters, because that what basically means that you are tuning your parameters according to your test accuracy, and that might get to it's not get to overfitting every time, like, but in yeah, out of 3 or 4 cases out of 10 it gets to overfit. I get your point, but mostly when you are learning, like, it's a beginner talk, so I'm not going into deep about overfitting or grid search CV or anything else. So that's why I didn't touch the validation test here. So when you start, when you are starting with a Kaggle competitions or anything, you go with the this training and test. That's it. And like the test that they provide is basically our validation, right? Because we cannot see their test up until the competition is over. So yeah, I get your point. Yeah.
Any other question? There are no questions. Everything is clear? Okay. So that's it. For your attention.
If anybody wants slides, it's up there. The link is up there.